So this is the 13th session on signals and systems, and we are going to study the combined operations. And which operations we are combining? Shift and reversal operations. So it is possible that you will first shift the signal and then perform reversal operation. Or it is possible that you first do the reversal and then do the shift. Now the shift itself can be either advance or delay. So you can have number of possible combinations, and we are going to study this. So let us start. So the first case that we consider is that we first advance the signal and then reverse, and let's see what we get. So sequence of operations, let's say xt is given to us. So right from -10 up to -2 it is 0, then it increases linearly, then it decreases linearly and becomes 0 at 5. So this is our xt, and what we do is we first perform advance operation on this. So when we perform advance operation on this, we know that the whole waveform shifts to the left. By how much time it will shift, it depends on the value of d. So we are considering a specific case in this case where the d has a value which is equal to 2 seconds. So this waveform will shift to the left by 2 seconds. So this -2 point will now start from -4, and here it was ending at 5. So it will end at 3 because the whole waveform has shifted by 2 units. Okay. Then what do? Then you time reverse this signal. So this becomes y1, y of minus t, that is x of minus t plus d. Note that this t time that is reversed now. So what will happen now? So remember, along the y-axis you basically rotate the signal through 180 degrees, or another way of looking at it is you start from the end and read all the values backward and then plot them in the forward fashion. That is one way of looking at the inversion. So when you invert this, this is what you will get. You can see this was coming down to 0 at +3, whereas here it will start from -3 and will increase linearly. And note that here it was starting from -4, so here it is ending on +4. So if you perform the sequence of operations which are advance followed by the reversal, this is the result you will get. Now the same result can be obtained by interchanging the operations, but then advance, you don't use advance but you use delay. So let me explain. This is a different way. So what we want again is x of minus t plus d. This is what we want. But what we do is we can manipulate this, take out the minus sign common, then you get t minus d here. So this points to the fact that you can now inverse the signal first and then delay it. So what we do is sequence in this case is first fold y. Fold y is same as taking time inverse. So y is equal to x of minus t, and now delay y by d. So delay y, so x of minus, and now this t becomes t minus d. So understand that if you open this bracket now, you are getting the same signal as in the previous slide that I have shown, that is x of minus t plus d. So note that you have changed the order of operations. There it was time shift followed by inverse. Here we are doing inverse followed by time shift. But the nature of the time shift in 2 is different, and therefore although you have changed the sequence of operations, you will still get the same result. So let me show that to you. So you start with the xt, same as in the previous case. Then you fold this first. So this is how we have discussed the folding already. So this 5, instead of ending at 5, it will start from -5, and instead of ending at 2, it will start from -2. That is what folding does. And then what do? You delay by d seconds. So if you delay by d seconds, if this was starting from -5, then it will now start from -3. Okay, and this was ending at 2, So it will now end at 4 seconds. So this is the output that you will obtain. So notice that in both these cases the final output is same, although the nature of the time shift operation is different and the sequence of operations is also different. All right. So this shows the comparison. So this is first method, this is the second method. So in this case, what did we do? We started with xt. I'm just summarizing it again. So we started with xt, then we advanced it by 2, and then we inverted, and we got this. Here we started with xt, then we inverted first, and then perform the delay operation, and you can see that you get the same result. All right. So the two of the possible sequences we have studied. Let's study the other two now. Different combination. So suppose we want y equal to x of minus t minus d. This is different than the previous case where we were obtaining x of minus t plus d. Okay. So one possible sequence of operation is like this, that you delay xt by d seconds. In that case, you will get y, which is xt minus d, and then you perform the fold operation on y, which means the time reversal, time inverse, whatever way you call it. So this becomes x of minus t minus d. So that is the final result that you wanted. So you first delay and then fold. So let's see what we'll get. So we started with the same xt. Now we have delayed it by 2 seconds. So instead of starting from minus 2, it is now starting from 0. Shifts to the right. Okay. And then you fold this. So it gets rotated around the y-axis by 180 degrees. So note that this was ending at 7. Instead of that, it is starting from minus 7 now. And this was starting from 0. It ends at 0. So note that you are getting a similar result, except that your overall shift is now different compared to the previous case. Now the same result can be obtained by changing the order of operations and then changing the nature of the time shift. So let us see that case also. So again, we want the same x of minus t minus d. So in this case, now what we are doing is, we are doing the folding operation first, and then we are doing advance. Remember, in the previous case, what we had done was, we had delayed first and then folded. We are now folding and then advancing. So you start with xt, you fold, again you get this as usual, but now you advance this. So the whole waveform will shift to the left by 2 units. So this was starting from minus 5, it will now start from minus 7 seconds. This was ending on 2. So since the whole thing shifts to the left, it will now end on 0. Okay. So this is a different way of doing it. Again, you can compare the two and you can find the same result here. So you started with xt here, delayed by 2 seconds and folded. And here you started with xt, first folded and then advanced, and you get the same result. So we have seen basically all combinations of the inversion operation and the time shift operation. And that's all in this session.